Okay, so these guys start off 34 centimeters from each other. Now, of course, there's all kinds of potential energy. These guys are going to fly apart when you let go of them. And so the question is, if you let go of them simultaneously, they're each going to have the same velocity, which is good. So they'll share the kinetic energy. And when they are very far away, they'll each have half the total potential energy of this situation here. Okay, so we can figure out their speed by doing that. Okay. Now, if they had different masses, this would be a much more difficult problem because we'd have to simultaneously solve momentum and energy, right? And if we release them at different times, God help us, we could figure it out, but it wouldn't be super simple. Okay, but they release them at the same time, so therefore these guys are going to be going the same speed, therefore having experienced the same amount of force for the same amount of time, right? Okay, so we can just take this potential energy, divide it in half, so that's what we're going to do here to solve this. Okay, so our potential energy of this situation is K times 45 E minus 6 times 45 E minus 6, and that is divided by 0.34. Okay, so let's figure that out. I can do this. Where is it? I've already done this. Okay, hold on. There it is. And I used it. Okay, there we go. So this is 53.54. Okay, now since these guys are moving out here, they have they're very far away, right? How far? Well, at infinity, the potential energy is 0, right? Because this thing divided by infinity is going to be 0. So all of that turns into kinetic energy. They each have the same amount, so I can just divide this by 2. And each one has 26.77, so 26.77 joules each. And now I can figure out their velocity, right? 26.77 is 1/2. Our mass is 0.056 times v squared. Yeah, you gotta be careful though. Times 2 divided by 0.056. And now let's take the square root of that. I'm getting 30.92. Ta-da!